G'day. In this series of videos, we're doing some auditory psychophysics using Psychopy and Python and some other libraries as well. If you haven't seen the other videos in this series, you haven't missed out on too much. There's two videos, an introduction video, and the last video was one where we used Audacity to make our sound stimulus. So if you want to just quickly go back and bring yourself up to speed, go and do that. If not, let's get cracking. We're all about the Python now. So we've got our Atom text editor on the right. We've got our command prompt on the left. I'm down there as well. Hello, you can see me. And Lionel, there's Lionel. Hello. Let's get cracking. We're going to start our Python script with the multi-line doc. And we're just going to use this to remind ourselves what we're going to do. We're doing an auditory psychophysics experiment. And we're loosely basing our stimulus based off Tan et al. 2008, and that was a hearing research paper. Right, good. And the sound stimulus that we're using is, it was a 250 millisecond tone burst, 10 milliseconds rise fall time at, oh, where's the at? 1 kilohertz. Great. Interstimulus interval was, what did Mike use for his interstimulus interval? 250 plus 1000. So he timed out at 250 and he had 1000 at the start. So let's make that say 1500 milliseconds, roughly. Actually, no, let's split it up. So 1000 pre-trial time, so 1 second pre-trial, and then he had 250 milliseconds time out. Okay, it was a 2 interval force choice. We're going to go through that, and he used a 4 down, 1 up, and that will converge on 84.1% correct in the psychometric function. Again, these numbers will make sense in the future. We're just vomiting it down here for later. I think it's 4 down, 1 up for 84.1. Let's have a look. 84.1, yep. So he's using that off Levitt 1971. We could do a 2 down, 1 up. That will converge at 70.7%. We could do a 3 down, 1 up. That will converge at 77 or 78% or something like that. 78.4 maybe. Anyway, these numbers will make sense in the future. We need to do some importing right at the start. So we need to get import pandas as PD. So pandas is going to be useful for us to create the experimental file that the responses will be saved into, and then that will save it as a CSV file for analysis later on. We also need from Psychopy. So from Psychopy, we will need the following. We'll need to do core, that will do the timing. We'll also need to grab event, because that's what's going to record the events from the keyboard. We will also need to play a window, so then we could tell the subject what the current state of play is. So we'll need visual. We might need logging as well, because I'm using a Dell laptop here from the 1400s, you know, when Gutenberg was making his books. So we want to turn off all the nonsense that comes out. I think that's about it. We want to import OS. We'll also import Wave. And we'll also import PyAudio. Let's see, I don't know if PyAudio is capitalized or not, so we'll just run that program again. Invalid syntax. We forgot to tell it to import. Import. Bitter. Okay, it's doing all of that. This is the first time it's run, so it's churning through all those imports that we're doing. It should speed up quite considerably in the future, so that's good. So yeah, PyAudio is lowercase here. So the first thing we're going to do is we're going to go if underscore name equals main. So this is a way of basically saying, okay, we want to do the following if we are running this script as an independent script, not if we're importing other stuff from elsewhere. So this is basically just saying only do the things that are in this script for the following. So we want to define a function now, and we're going to call this clear output. This function is going to take no arguments, okay? Because what we're going to do is we will use this function to clear the command prompt. And so what we're going to do is we'll go clear output, like that. So now, this should do nothing because we've just got that pass statement in our function, which means just pass over it. So it's printed out debug hello world. That's great. So what do we want to do? Well, we want to clear the output of our command prompt, because if we've got all this history in there and we've got these error messages coming up, we want to just try and make it easy for us later on to just only have as an output that which is most recent to the program that we've created. So what we can do is we can go os.system, so make a system call, and we want to pass the following CLS if os.name equals nt, else we want to do clear. What this is going to do is it's going to make a system call and it's going to pass CLS to the system if the name of the system is NT. Now that's how we denote Windows machine. So if it's a Windows machine, it's going to go CLS. But if it's not a Windows machine, it's going to go to this else statement. So if it's a Mac, if you're running on a Mac or a Linux machine, it's going to pass clear. And remember how we clear our command prompt here? What do? We type CLS, and that clears the command prompt. So this is a way that we've got an ability for the program itself to clear the command prompt. And we've also done it so that it will work across Mac, Linux, and Windows machines. Okay, one line of code, very versatile. So let's give it something to clear. And we'll put this debug statement here. So Control X, debug, clear screen. Now you'll notice that this clear screen print statement comes after we've cleared it. We've made the system call. So all that we should get out of this program is, oh, I just cleared the screen again. Let's run the program. We should get debug clear screen. What do we get? There we go, debug clear screen. So we have now got it working. So this, every time we run this program now, we're going to clear the screen. And this can be helpful later on. So we've got our first function here. Let's make our second function, and we're going to call this, we'll call this we'll call this experiment update. Again, we're not going to pass any parameters to this. This experiment update, okay, so we'll just make a pass function here, and we'll go experiment, update. In this experiment, in this bit, we are going to basically create the user interface, the user update experience interface. So what do we want this subject to see when they're doing their auditory psychophysics experiment? I'm just going to call it experiment from now on. Well, I think we want to basically have them to just view a very boring grey screen. So then their attention is not taken away to other things. So that could be your experiment. Hey, what's the effect of visual stimulation and auditory stimulation on auditory thresholds or something like that? In fact, Mike did some experiments like that where they took people with perfect pitch and relative pitch and did some experiments. But for us, we just want a very boring blank screen. So we're going to use the psychopy visual functions here to do that. So we want to make a window, so we'll call that win0 equals visual dot window. So what do we need to do? Let's just make it a small one at the moment so we don't crowd stuff out. So we'll make it, say, just a standard, let's make it a 300 by 300 window. We want it on this screen and not this screen. So we want it to come on screen 0. So the main screen is going to be screen 0. I've got another screen here. That's going to be screen 1. So you can choose. If your subject's doing their experiment in a soundproof room, which they should be doing it because it's an auditory experiment, you may have a monitor in the soundproof room, and you might be monitoring stuff on your computer here. So obviously you would select different things to appear on different screens. Okay, so here's the way that we can do that. Now we are going to basically use the test monitor. So if you needed to calibrate your visual system, your visual display, like your monitor or your projector or something, and you had the gamma correction tables and your RGB, so your gun correction values and all that sort of stuff, luminance and contrast and stuff, you can go into Psychopy and basically save a calibration file, calibration file in this monitor, the monitor center. We don't need to do that, and I'm not going to do that, so I'm just going to use the one that comes with the program, and it's called test monitor. You will need to do that to calibrate your output device if that's what you're doing experimentally. So size is 300 by 300. The screen is 0. The monitor is the lookup tables. We'll hit enter just so it cleans it up a bit. The color of the screen, so that's American spelling, unfortunately, is the color of the screen will be, so this is in red, green, and blue from -1 to 1. -1 in all 3 channels will give us black. 1 in all 3 channels will give us white. Let's just give our subject a boring gray color, so we'll go 50% of each. 0 is 50% between -1 and 1. All of the colors are the same intensity, so it's going to be gray. It's going to be a mid-gray. Now, full screen is false because we've only going to give it a window. The units that we'll run here is pixels. Let's just clean that up a bit. Pixels, and we want allow GUI. So that means when you create a window, do you still want to see the bar up above with the X, this sort of stuff up here? You see up here, you've got the minimize, the maximize, and the close window. So this thing here, if you set that to true, it will still be there. If you set it to false, you're literally just going to come up with a window with nothing around it. We will leave it on for now, just because it means that we can debug things and move things around a bit easier, should it be required. I think that's all we need for now. So we've created our window. We need a stimulus. So let's create a stimulus. So we'll call this stim1. We'll call this, text1 visual dot. Now, I need to remind myself how to make this text, because we want text to appear on the window, because remember, Mike gave his subjects, I remember doing these experiments, he flashed the number 1 and the number 2 up, because there was 2 time points where the sound would be played. It would be played either at this time here, and number 1 would come on the screen, or it wouldn't play at number 1, but rather it would play at the second time interval, and the number 2 would appear on the screen. So you see, I had to choose, or the subjects had to choose, was the sound in the first time period or the second one? That is the 2 interval forced choice procedure. I was forced to choose 1 or 2. It wasn't both, and it wasn't neither of them. It was 1 or 2. So that's a 2 AFC. He's called it an IFC because there's 2 intervals. All right, so we need to make a text appear on the screen now that says 1 or 2. So let's go back to our atom. So the text is going to be visual.textstim. So sorry, let's have a look at the documentation from psychopy.org. So documentation, text stim, so it's capital. Let's grab all of that. Control C to cut. We don't need all of this. We'll just give it the minimum parameter set. Control V, home, I'll hit Control S and then hopefully Atom Beautify, which is a package that I've downloaded for my Atom text editor, which basically brings it into, I think, close to being, it beautifies the window, the text that we've got here. So let me just bring all these down. Again, we don't need all this stuff, guys and girls. We don't need text hello world. We want 1, because we only want the number 1 to appear. The font, we'll make the font Arial. The position, now this is going to be relative to the window, so 0, 0 is going to be dead slap bang in the middle of the window, and that's fine. That's what we want. The depth, we don't care. RGB, we don't care. The color, we do care what color it is. Let's make it black on gray. So black, remember, we need nothing in the red, nothing in the green. Whoops, I've just done something. Nothing in the green and nothing in the blue. So let's clean this up. Color space, we don't care about. Opacity, we don't care about. Contrast, we don't care about. Units, this will be pixels. Orientation, we want it up and down, so that's fine. That's height. Let's make this, say, 18. Initialize true, bold, false, italics false, align horizontal false, wrap files. We don't need any of this stuff here. So we'll clean this up. There we go. So there's our first text stimulus. We will then make our second text stimulus because we want to make either the number 1 appear or the number 2 appear. So 2, so this text will be text 2. Everything else is going to be the same. So let's see if we can make this appear. So we've got our window in the memory. We've got our text stimulus in the computer memory. We need to then draw the text stimulus into the window memory, apply it to it, and then we have to flip the window from memory onto the screen. So there's 2 things we need to do here. So let us just make the text1 dot draw. So this will draw the stimulus into onto the window. But remember, it's still in memory here. And then we need to flip from the memory onto the screen. So we'll now go win0, because remember, that's the window that we created. Dot flip onto there. And then what we're going to do, just for this first experiment, just to see if it's working, we'll go core.wait, which means we're going to wait for a certain period of time. And we're going to wait for, say, 3 seconds. Let's make it 5 seconds. So it gives us a good chance of seeing it. And then what we're going to do is we'll go win0.close, which means we're going to close that window back down again. We're going to tidy things up because we're good programmers. I'm not suggesting I'm a good programmer. It's just, it's a good habit to get into. So we're creating a window. We are creating 2 different text stimuli. We are then going to draw just the first text stimuli. So we should expect to see the the number 1 appear on our screen in the middle. We don't need that much precision. So it's going to draw the text 1 onto the window, and it's going to flip the window from the memory onto the screen, and then it's going to wait 5 seconds, and then it's going to close everything down. Experiment update is the function that we've created, and we're going to call that only once. Let's see what we get. Hopefully we've not made any mistakes. Okay. Text stim 1. Win is not defined. Okay, and then we've got this pesky annoying logging errors. So, okay. I've called it win0, whereas I said, hey, can you draw it onto win? And I haven't set that as the name of the window. Are other processes running on your computer? Yes, I'm running OBS. So fingers crossed. There it is, bang. number 1 is on the screen. It's a bit small, hey. See if we can make that a bit bigger. Maybe we need to turn bold on. There we go, that's a bit bigger. Okay, good. So that should be about 5 seconds, and then it has closed everything down again. Great, so we're starting to get the user experience all up and running. What we can do actually is we can create just a template for our text stim. So we'll call this text stim. Okay, we don't need that now. What we will do up here is we'll create our, text 1 equals 1, text 2 equals 2, and what we'll do is we'll go begin text equals begin. We'll just say begin. Okay, because what we can do now is the text, we can refer to the text as begin text. All right, and then this should work. So we don't need to make 5 or 6 different text stimuli, we just create one stimuli, but then we change the parameter of the text within that text stimulus. So this should hopefully write begin in the middle of our window that we create. It should still play it for 5 seconds. So what have I done wrong? Text 1 is not defined because, okay, that's stim. I'm going to leave all these errors in there so you can see the problems at making spelling mistakes and silly emissions and stuff. Text stim has no attribute called stim. Okay, text stim.stim. Line 37, text stim.stim. Okay, because that should be draw. Okay. I'm making lots of mistakes here. That's okay. We're here to learn. Begin. Haha. Ça va. Ça commence. Super. Sehr gut. There we go. All right, what's the next thing? Well, let's see whether or not we can get a little bit more control over this experiment. Let's create a loop. Let's just say while true. So while the following statement is true, we want to, we don't want to wait anymore. We want to, oops. We'll put this down here. We need to indent now. So while true, we want to text stim.draw. So we'll text stim.draw and when 0 dot flip. Okay, now we want to start getting some keyboard input. So we want to get some keyboard input. So we'll say keyboard input equals event. So this is from the Psychopy event module, event.waitKeys. And we want to give it a list of keys that we want to look out for, okay? So that means that if your subject accidentally presses the wrong key, then it's not going to abnormally control your experiment. Basically saying, do nothing until one of the following keys is pressed. So we have to choose a key. So let's have a look at the dictionary here. We'll go to not text stim, we'll go to waitKeys. Oh, not found. So let's just go Psychopy waitKeys. Psychopy.event, okay. Not mouse, we want waitKeys. So here we go here, waitKeys. Maximum weight, infinity. Yep, that's fine for us now. The key list, this is what we want. Key list, it's going to be a list. Right, that's in the name, key list. Angie, you're an idiot. Right, so, what did they say? Key list, so lowercase k, so key list equals, we want to look for the following keys, Q. Now, we want to split up the keys so that, you know, number 1 is, say, F, because on this keyboard here, the F has a little sort of bump on the F, and J has another little bump as well. So we'll make J number 2, and we'll make F number 1. So was it in the first window, they'll have to say F. And if it was in the second window, they will make it, too many there, what did I say? J. Okay, good. Then you say if Q in key, we want to break. That means that if you hit the Q button, okay, we'll break out of this loop and we'll close the program down. The other thing that we need to do is make sure that every time we look for the wait key, we've cleared the buffer of any key presses that have been made before this event.waitKeys has been called, okay? And that's called clear events. So clear events means you want to clear the event buffer and discard preceding key presses before starting to monitor for new key presses. So clear events equals true, lowercase c, uppercase E. So clear events equals true. So if Q in key, so if, what was it? F in key, we'll say, what should we say? We'll do a print line, debug. What should we say? Window time point 1 pressed. Okay, and then we'll go if J in key, print, print debug time point 2 pressed. Okay, brilliant. If they press the Q button, it will then break. So this should, in theory, continue to draw the text stem when 0.flip, and it should give us the same output, and it should print out these debug statements. If we press the F or the J key, if we press another key, it should do nothing. And if we press the Q key, the Q button, then we should break out and close the video. Close the program, not the video. So let's run this. What errors have I made? Oh. So we're not updating any of the stimuli or the text stem. We're just basically getting something that resembles a program to run. So I'm going to hit the F, and I hit the F. You can see here it's printing out time point 1 has been pressed. I hit the J, time point 2 is pressed. F and J together. Now I'm going to hit the T button. It's doing nothing. The B button, space button, nothing happens. I hit the Q button now. Oh, everything closes down. Great. Right, the next step. We don't want to keep this going on forever and ever and ever, although it does feel like that when you do the experiments, because they are quite boring. So let's set a counter, so the number of trials. How many trials do we want to do in our experiment? So I know from memory that Mike did 105 trials per session, and that we did 2 sessions per day, or per block, and I think I did 2 blocks per day. Let's just confirm that. A session consisted of 105 trials, took 10 minutes. The observers completed no more than 4 sessions in a single day. Yes, so I remembered correctly. Good. So we want to do this 105 times. So number of trials equals 105. So while true, so we don't need the while loop anymore. We'll say for I in range 0 to number of trials. So this is going to start a counter, essentially an iterator, I, and it's going to go through around and around and around until we've reached the number of trials. But to do this, we need to now increment and have control over incrementing the iterator. So what we'll do is we'll print here I equals I plus 1. And what we'll do is we'll print out trial number. Okay, so every time that we push the F key now, we're going to increment the trial by 1, and we're going to print out the new trial number. Actually, no, what we'll do is we'll print out the previous trial number. I'm going to increment the trial number. This is the long way of doing it, so what we can do is I plus equals 1. So we're going to increment it by 1. And then we're going to do the same thing for j. So j, I plus equals 1. Bop, bop, bop. Comes up. And then we don't need to do anything if break. If we break, we won't make it 105 because that's too long. We will put a comment in here, 105 trials, 105 trials in actual experiment. We'll just do 5 trials. Let's see if this works. Begin, F, trial number 0, that's good. 1, 2, 3, 4. How many did we do in total? 1, 2, 3, 4, 5. So we did 5 trials. Remember, Python does zeroth counting. So it will start counting from 0. And when we do a for loop, it will include the lower bound, but it does not include the upper bound. Okay, so we did 5 trials in total, but we started counting from 0. All right, so we can now control the numbers of our trials. We can set that, and we can now get keyboard input into our program. We're going to leave this video here. In the next video, we're going to see how to update or control the timing of the experiments. At the moment, we're doing nothing until the user presses a key, the keyboard. What we want to do now is start to say, okay, we have to time some of the information. All right, we'll leave the video here, and I'll see you in the next one. See you then.